Another section. Today we're going to do some test review. We're going to start with chapter section 1.5, 1.6, then we're going to move on to chapter 2, 2.1, 2.2, and 2.3. Let's start out with this example here. Each inequality. Okay, we're going to go ahead and graph this inequality. So we have it says x is between 0 and 4. At the same time, it says as x is bigger or equal than 0, smaller or equal than 4. So we're going to go ahead and make our line here. We talked about it. If we have this symbol right here, bigger or smaller, we use parentheses. If we have this symbol, it says equal, then we use bracket. Okay? And here we're using this. So we're going to have, this is our 0 line. All right, 0, and then 1, 2, 3, 4. So 0 is included, and therefore our line is going to be like here. And this is being 4, and also this is going to come same way. That's the graph. And you can go ahead and leave your arrow this way. So let's go to another problem. Second problem we want to do is 3x minus 7 is bigger than 2. And the problem says solve the inequality, express your answer using sets of notation or interval notation. So we're going to just solve this. So we're going to make it look like here and find out where our x is. Let's get rid of this negative 7 first. So we're going to have 3x bigger than equal, bring negative 7 over here, and it becomes positive 7, so it becomes 7 plus 2, and therefore I have 3x is bigger than equal 9. Now I want to get rid of 3, so what do? I drive both sides, I divide both sides by number 3. So 3x divided by 3 bigger than 9 divided by 3. These two cancel each other out. I have as x is equal bigger than 3. So there it is the, and if you want to graph it, it would be like here, and this being 0, 1, 2, 3. Remember, it's bigger than here. There's no equal sign, so we're going to use a parentheses. So it's going to be x is bigger than 3. So it's bigger than 3 is like this, and it's going to go forever. There you go. Saying this is 3 and infinity, because it's from here forever. Let's go do this second problem on absolute value. We have this problem. It says 2x is equal 6. So that's same as saying really 2x is equal 6, or 2x is equal negative 6. So now we have two different equations we want to solve. So divide both sides by 2 and become 2x divided by 2 equals 6 divided by 2. Your x is equal 3. Same thing over here. 2x is equal negative 6 divided by 2. And then you have x is equal negative 3. We get two different answers. And that's how you solve this one. And we can write it down as the solution set can be write down like as 3 and negative 3. So you got this inequality, and we talked about in class that there was a format, an equation that we used, you can see on the table here. We're going to use the second format, and we have this inequality 1 minus 2x absolute value bigger than 3. So this could be translated to either 1 minus 2x smaller than negative 3 or 1 minus 2x bigger than 3. Then we solve this all the way, and we're going to graph it. And this is based on an equation that's shown on a book. Well, let's solve this one. So become 1 minus, let's get rid of the 1 first. So it's going to be negative 2x less than, that become negative 1 minus 3, and this one is going to become minus 2x bigger than equal than negative 1 plus 3. So I have negative 2x less than or equal negative 4 and or negative 2x is bigger than plus 2. So divide both sides, and here you got to be careful because we divide them by negative, and we talked about if we divide by negative, things go into flip. Negative 2x divided by negative 2 and divide negative 4 divided by negative 2. Since we divide by negative 4, we're going to end up flipping. And here, same thing. We're going to have negative 2x divided by negative 2 and plus 2 divided by negative 2, and that's going to flip. So it's going to go this way. And now that's going to be positive x here and bigger than positive 2. All right, and this one is going to be negative will become x less than negative 1. So now we have two different situations there. And if we had to graph it, it's going to be says x is less than negative 1. So it's from negative 1 all the way to infinity. Therefore, I'm going to say, okay, it's negative infinity all the way to negative 1. And this one, union of this one is bigger than 2 all the way to positive infinity. So it's going to be 2 and plus infinity. Now, if this was an equal sign here, our parentheses will turn to a bracket. So if I want to just graph this, I'm going to go ahead and have my line here. All right. Need another one of these here. There we go. So let's say this is 0, 1, 2, and I need negative 1. Negative 1 is right here. And this one says is x is negative 1 forever. It's going from here. So it's going to go forever, and it's going to be parentheses. This one says 2 and ever, so it's going to be 2 from here, and it's going forever like that, and that's how it's going to look like. All right, we're going to go ahead and move on to section 2.1, and here it's giving us this coordinate, and it says I got this coordinate here, and it's 2 and 5. So that means this is 1, 2, 1, 2, 3, 4, 5, and this is the point I'm looking for. Now the question asks if that point is shifted 3 units to the right. So it's going to go 3 units to the right. That means x is going to go 3 units. So it's already here. This is 2. This is already 5. So it's going to go 3 units this way. That means 2 minus 3, which is equal minus 1. And also, no, to the right. The other right. Sorry. I was going to the left. There's 1 point for you guys, right? So it's moving to the right. So this point is moving 3 units to the right. So this is 2. That means it's going 3 units to the other side. So that's going to be 5. Like 1, 2, 3, 5. And 2 units down. So it's going to 2 down. It's already 5. So it's going to go down by 2 units. So that's going to be 3. So our new point is going to be 5 and 3. And you can plot it. The second problem we're going to do is says if the midpoint of a line segment from point P1 to point P2, and this is be right down the middle, the midpoint is negative 1 and 4. Negative 1 and 4. Of course, this means in Cartesian coordinate. And if P1 is equal right here, and that's equal negative 3 and 6, negative 3 and 6, then what is the P2? So what is the P2? Okay, so we know that the midpoint, which is the x and y, if we call this midpoint is x and y, and P1 is x1, y1, P1 is x1, y1, and P2 is x2, y2. And we can use the formula that we had. Was equal, what was it? X1 plus X2 divided by 2, Y1 plus Y2 divided by 2. And we already know this. We know this. No, we know 0.1 and 0.2. So we're going to say, okay, this is my x, comes out to the x, and this is comes out to the y, right? Because m is equal x and y. And therefore, let me come over here, and I'm going to say for the x part, the x part of that, x is equal, that's the midpoint. That's -1, that's x. If I call this mx and y, this will be x1, y1, and this will be x2, y1, x2, y2. So that x of the m, it's going to be x1 plus x2 divided by 2. We know already x for the midpoint is given as -1. So we're going to say -1 is equal, and we know x1 is given as a -3. -3 and plus x2, which we don't know, which is on the other side, they're asking for that, and divide by 2. Okay, so that's easy to solve. Now I have -1 equal this thing here. So I'm going to go ahead and say, what if I just say they put a 1 underneath here? I haven't changed anything. So it'll be this time this, this time that. Cross multiplication, I have -3 plus x2 is equal 2 times -1 minus 2. Oh, we got something here. Let's get rid of -3 from on that side. So become x2 is equal -3 become +3 minus 2. And x2 comes out to +1. So there's one of them. x2 comes out to +1. Let's find the y now. Okay. To find the y, we do the same thing. We say y is equal, for the midpoint right here, is equal y1 plus y2 divided by 2. And y, it was here, turned out to be 4. So 4 is equal, and y1, it turned out to be 6. 6 plus y2, which we don't know, and divided by 2. Same thing. All right, so become 2 times 4 become 8. And 8 is equal 6 plus y2. And therefore, y2 is equal, I'm going to get rid of a 6 from on that side, become negative, become 8 minus 6, which y2 comes out to 2. So now the point I'm looking for, it become 1 and 2. Okay. And this is equal to P2. We have this equation, and we want to find out, it says plot the x-intercept and y-intercept and graph the line. Well, this is x. When you have an x-intercept, that means what? That means your y is 0. That means wherever I'm going to make a line, it's going to cross the y. Doesn't matter where I cross the y, here, 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 here. No matter where I cross this line of y, that means what? That means x is 0. And the same the other way. If I want to do the y-intercept, then whatever I'm going to cross the x line, and what happened? My y is 0. So let's find the first one first. Okay, we're going to say 2 times 0 is equal, oops, not equal. That's a plus 3y is equal 6. So that becomes 0. So 3y is equal 6. And divide both sides by 3. And I'm going to have y is equal 2. That means y is equal to 1, 2. That's one point it's going to cross. So now if I'm going to go ahead and make y equal 0, I'm going to write the same thing. I'm going to say, okay, 2x plus 3 times 0, and that's equal 6. And I have 2x is equal 6. Divide both sides by 2. And I have x is equal 3. And I'm going to have 1, 2, 3. And I'm going to have a line right here. And this is my line right there. There you go. And that's it. They give us this line. It says find the equation of line. They give you 2 points. And they want you to find the line. So first thing we're going to do, remember, we talked about line being y is equal mx plus v, right? And that's the slope of your line. Let's find the slope of line. Slope was what? Rise over line, remember? Right, okay, so m is equal is we can say y2 minus y1 divided by x2 minus x1. In this case, m comes out to y2 being 1 minus 0 divided by x2 being 2 minus 0. So your slope of your line is 1/2. We got that out of the way. Now we want an x-intercept. Our x-intercept is what? 0. It's already given. So now we have our y comes out to 1/2 of x plus 0. And no matter which way you look at it, you can rewrite this. This is the best way to do it. It just says y is equal 1/2 x. Or I could say, well, what about if I say multiply both sides by 2, they become 2y is equal x, or you can say 2y minus x is equal 0. All this same means the same thing, but the best way to show it is this one right